Okay, so good morning everyone. Good morning once again. Okay, so today we are going to solve the problems of 13.1, primarily 13.1, and we'll try to complete, okay, chapter 13, but we will be solving more problems today because tomorrow is empty, so I won't be teaching any new concepts. Okay, right? Okay, so I hope all of you have gone through the problems. Tell me, all of you have gone through the problems. 13.1, mute yourself. Raise your hand. How many of you solved it? 13.1. Yes. Okay. At least in class exercise, right? Even if you haven't solved homework, no issues in class exercise, or at least you should have gone through the problem. Okay. Now, I hope all of you understood these concepts. The concepts that were covered in this topic was first, the basic of periodic motion, right? Then the condition of SHM, then restoring force, the formula of velocity, formula of acceleration, okay, of the particle which is having SHM motion, right? And then the kinetic energy, potential energy. So these are the topics that we have covered already. Okay. Okay. So let's see the concept. I'll revise the concept once again. So if you see the concepts, I can say we have a basic idea about periodic motion, oscillatory motion, right? What is harmonic motion? Okay. Then we saw that what is phasor, right? How the phase is associated with the motion of the object, right? So it can be described as the shadow of a particle which is moving in a circle, right? Yes or no? It can be described as the shadow of the particle which is moving in the circle, and the angle covered by that is your phase. Okay, right? Now, when you talk about harmonic motion, we have two types of harmonic motion, which is linear and angular. Okay, right? Okay, so when we talk about some important formulas, so we talked about displacement. The first formula was displacement, then angular frequency, velocity, acceleration, time period. Yes or no? Right? So this is the graph of displacement. Now, in this case, what is the phase? Tell me, what is initial phase? Tell me, everyone, what is initial phase in this case? You can tell me just by looking at the graph, what would be the initial phase? The initial phase here is 0, right? Because at time t is equal to 0, it is starting from 0. So the initial phase is 0, right? So the equation would be y is equal to a sine omega t or x equal to a sine omega t. Now in this case, this is velocity, right? This is velocity and this is acceleration. Okay, so let's solve these pre-reading questions. Easy. So 1 to 5. Question number 1, everyone, please respond. Question number 1. Question number 1. In the equation x is equal to a sine omega t plus delta, the term omega t plus delta is very good. Phase, very good. Very good. Okay. Now, second one. Projection of uniform circular motion on the diameter of a circle, right, is a simple harmonic motion. True or false? Easy, right? Very good. Very good, Akshay. True. Very good, Jitendra Abhiram. Very good. Third. The velocity of particle undergoing SHM is dash at the extreme positions. Very good. 0. Very good, everyone. Right? Very good. Fourth, the acceleration of the particle undergoing SHM is always directed toward or away the center of the oscillation. Tell me. Very good. Very good. Toward. Very good. Fifth, every periodic motion can be simple harmonic motion. True or false? Very good, Akshaya. Very good, Abhiram. Very good, Jitendra. Correct. False, right? Because every periodic motion cannot be, right, harmonic motion. Very good. Now, in class exercise, question 1 and 2. Question 1 and 2. Easy. I hope 1 and 2 everyone have solved. Yes or no? Raise your hand. Question number 1 and 2, everyone have solved? Anyone have any doubt in question 1 and 2? You can ask. Tell me question 1 and 2. Anyone have any doubt? So when you talk about question number 1, okay, I can say in question number 1, think about it. Clear? Very good, Soumya. So the particle executes simple harmonic motion between x equal to minus a and x equal to plus a. The time taken for it to grow from 0 to a by 2 is t1, and from a by 2 to a is t2. We know that. The answer is, tell me, what is the answer of 1? Tell me, everyone. Right? What is the answer of 1? Yes, very good. Correct. Yes. Pendulum example. Yes. So the answer is, tell me, everyone, what's the answer? A, B, C, D. I'm getting 2 answers. Yes, think about it. Now, answer should be A, right? Concept. Because think about it, right? If you talk about pendulum, so when it reaches, so this is A by 2, this is A, okay, right? So this is 0. So from here to here, the speed is more as compared to here to here. Yes or no? Tell me. Yes or no? And we know that time is equal to distance by speed just by visualizing. Yes? Clear? Easy? Okay. Second one. Phase difference. So I hope all of you can find. You can convert this into one function. Need students? Do you remember? Yes? That you can convert this into one function. Right? Yes or no? Yes or no? This can be written as 1 by 2. This can be written as cos 60 degree. Cos 60 degree into sin omega t plus sin 60 degree into cos omega t. Yes or no? Yes or no? Which is basically sin omega t plus 60 degree. So what is the initial phase? Tell me, what is the initial phase? Y1. For Y1, what is the initial phase? Pi by 3. Very good, Siddharth. So second one you can solve. No, second one you can solve. You can just multiply and divide 1 by root 2. Okay. Right? Easy. Now, next. Three, four, five. Okay. Now, question number 3. Everyone, look at question number 3. Which question, Meet? Which question? Question number 3, everyone. Question number 3. Meet. That's correct now because two simple harmonic motion. This is y1, this is y2. This is 60 degree. This is 60 and this is what? This is 45 degree. Yes or no? And they're asking the difference between these two. Got it, Meet? Tell me, got it? I just gave you the hint. I didn't solve complete problem. Okay. Right? So y1 I said 60 degree. For y1 I said the initial phase is 60 degree. For y2 initial phase is 45 degrees. Phase difference is what? 15 degree, which is pi by 12, right? Sneha, Anjali, everyone is getting? Akshaya, Chulika? Chulika is absent, I guess, today. Okay. Now, question number 3, everyone. Question number 3. Tell me, these two springs are in series or parallel? Tell me, these two springs are in series or parallel? These two springs are in series or parallel? Series. And what is equivalent spring constant in series? Tell me, what is equivalent spring constant in series? Reverse, right? So I can say 1 by k equivalent, 1 by k equivalent is equal to 1 by k1 plus 1 by k2 in series. I hope all of you remember. Yes or no? I hope all of you remember, right? Yes. And what do you think about the force? Force will be equal for both or different for both? Equal, right? So if force is equal, can I say, right, k1x1 should be equal to k2x2? Yes or no? Yes or no? Tell me. If force is equal, can I say k1x1 is equal to k2x2? Right? And can I say k equivalent into x1 plus x2 is equal to f? Tell me. Yes? And this x1 plus x2 is nothing but amplitude. Yes or no? Tell me. Yes or no? Right? Right? Now, if I have to find what in this problem, you have to find what? Amplitude of point P, which is the displacement of K1, right? Displacement of K1. Yes or no? Tell me, guys. So I can say, okay, I want to find x1. So x1 will be F divided by K1. And F is what? This K equivalent into amplitude by K1. Easy? Tell me. Got it, everyone? Tell me. Everyone got this? And K equivalent you can find from here. So K equivalent is equal to K1 into K2 by K1 plus K2. Clear, everyone? Tell me. Clear? Yes or no? Raise your hand. Okay. How can you put directly K1 is equal to K2, right? K1 is not equal to K2, right? If it is not given that K1 is equal to K2 because X1 is not equal to X2. Who said they're in series and they are equal, right? We never discussed that in series the spring constant will be equal, right? Now, let's see question 4, everyone. A particle starts oscillating simple harmonically from its equilibrium position with time period t. Okay, find the kinetic ratio of kinetic energy and potential at time t is equal to t by 12. So we have seen this, right? We have seen this. We have solved a problem like this. Yes or no? How many of you remember? Raise your hand, right? It is the ratio of sine square theta by cos square theta. As simple as that, right? It's the ratio of sine square theta by cos square theta. Okay. Now, question number 5. Question number 5. Sneha, you're getting everything. These are basic formula putting getting problems. Tell me. Sneha, are you getting? Sanya, Anjali, Akshaya, Pradyumna, Shulika, Koshi, Kushi, Karishma, you're getting anything? Karishma, I've uploaded the videos of this. Are you getting everything? Tell me. Yes, okay. So fifth one, tell me, fifth one. Now this is your xt curve, right? This is your xt curve and it is sine curve. Okay. Now from this, I can say that it is starting from 0. So initial phase is 0. Okay, find the acceleration of the particle at t is equal to 4 by 3. Formula putting getting. We know that acceleration is equal to what? Minus omega square x. Yes or no? and it is given that x is equal to 1. This is 1 sine omega t. So a is equal to minus, tell me, omega squared sine omega t. Agree? Agree? No issues, Chulika. I'll record the class. Okay, you can watch. Tavishka told me that you guys are not in Vidyanagar, so it's fine. Okay. Okay. Now think about it. Fifth one, think about it. What is time period? Tell me, what is time period in this case? Because the only thing that you have to do is find omega. So what is time period? Tell me from this graph. You can find the time period. Now, what is time period? Everyone tell me, what is time period? This 8 seconds, yes or no? 8 seconds, right? Time period is 8 seconds. So omega is equal to, tell me, omega is equal to 2 pi by t, which is pi by 4. Clear? So I hope all of you can find it. Yes, agree, easy, got it? Okay, now question number 6. Question number 6. A point mass oscillates along x-axis with this equation. Okay, so initial phase is minus pi by 4, which is, it is starting from the negative side, yes or no, right? Negative amplitude. So if the acceleration is written by this, where x naught and a is greater than 0, find the value of a and delta. Now, can you find the value? Tell me, can you find the value? It is conceptual problem, right? You don't have to solve much. Tell me. X is given, you have to find a. Find a, na? Find a. So d square x by dt square is equal to what? Tell me. X naught omega square negative, right? Negative. Yes or no? Tell me. Right? Cos omega t minus pi by 4. Yes or no? Tell me. Minus omega square x. Agree? Yes or no? This is basic formula. Basic formula, everyone. But you have to make sure that the function is same. Whenever you find the phase difference, the function is same. So here it is a cos omega t plus pi. Here it is negative. So you have to convert this negative into positive. So what we have to do? I hope all of you know that minus cos theta is equal to what? Tell me. Minus cos theta is equal to what? Cos, tell me, theta plus pi by 2. Yes or no? Basic trigonometry, basic trigonometry. Yes. So I can write like this. Now it is minus cos theta. I can write like this. So it will be what? Omega square x naught cos omega t minus pi by 4 plus pi by 2. Okay. So if you solve this, what you will get? Tell me what you will get. Sorry, plus pi, not pi by 2. Plus pi will be cos theta, no, plus pi. My bad. Plus pi, because you have to find what? You have to find cos theta, na? It will become sine theta, right? So theta plus pi, na? Theta plus pi. So what it will become? It will be plus 3 pi by 4, right? So it will be omega t plus 3 pi by 4. Okay, because we have to get cos theta, na? So it will be pi, not pi by 2. Pi by 2 will become sine theta. Okay, clear? Right, everyone? So the answer of delta is 3 pi by 4 and the answer of A is omega square x naught. Easy? Clear? Okay. Now, Question number 7th. Everyone, see question number 7th. A particle of mass m is located in one-dimensional potential field where potential energy is given by this, where A and P are constants. A and P are constants, right? Find the period of oscillation of the particle. Tell me. Think about it, everyone. Tell me, what is the definition of potential energy? Du is equal to minus F dot Tx, yes or no? Tell me, yes or no? Yes or no? So can I say F is equal to minus du by dx? Yes or no? Which is equal to ma. And for time period, we just require omega, right? So du by dx, what will be du by dx? I mean, what would be du by dx? Differentiation of cos px will be what? Because a is a constant, right? So it will be 0. So minus cos px will give you minus sin px. So minus minus plus, and then we have minus. So it will be what? Minus, tell me, a, tell me, p sin px. Yes or no? Yes or no, f is equal to. Anyone have any issue in this? After differentiating, we will get this only. And we know that if for very less theta, sin theta is equal to theta. So sin px will become px. So f will be almost equal to minus a p square x. Agree? Tell me, yes or no? Tell me guys, yes or no? Right? So what is k? Tell me, what is k? K is equal to ap square. K is equal to ap square. And we know that omega is equal to root k by m. Easy? Tell me guys, easy? Got it? Got this concept? Sneha, Sanya, Shreya, Suhas, Vivek, Riya Singh, Riya Jha, Anamika, Priyanka, everyone is getting this concept? Pritam, Malik. Okay? Okay, very good. Now, question number 8. So this is acceleration displacement curve. Find the time period of oscillation. So we know that A is equal to basic formula getting minus omega square x. Yes or no? Tell me. Yes or no? Right? So what is the slope? Tell me guys, what is the slope of this? What is the slope of this line? Tell me, what is the slope of this line? Tell me, what is the slope of this line? Minus 1, right? And what is the slope of this equation? What is the slope of this equation? Minus omega square. Yes or no? So I can say minus omega square is equal to minus 1. So omega is equal to 1. Yes or no? Omega is equal to 1. Agree? Agree everyone? So obviously you can find the time period. Yes or no? Omega is 1, then time period is 2 pi. Clear? Clear everyone? Easy? Super easy? Yes or no? Was this problem easy? Okay. Now question number 9. Everyone is getting the concepts, everyone? Pradyumna, you're getting the concepts? Amish, Anga, Anisha. Okay, Mansi. Okay, 9th one. A particle of mass, this mass is given. It's placed at the lowest point on a smooth parabola. X square is equal to 40y. Okay, 40y. If it is placed slightly, and it moves, it moves such that frequency, right, in terms of g. Tell me, Think about it. This is a good problem. Tell me. This is a good problem, everyone. Think about it. So my problem is this is moving in parabola, right? This is moving in this parabola. Okay. Now, here x square is equal to 40y. So it is actually not this parabola because this is what? Okay, this parabola only, x square is equal to 40, this parabola only, right? So x square is equal to 40y. Okay. So I want to find what? I want to find acceleration. Yes or no? Tell me yes or no. Tell me. Okay. That's the basic thing. I want to find acceleration. Okay. And we know that we have two methods to find the acceleration. One is energy method, one is force method. Okay. So you might not get how to use the force method over here, but we can always use energy method. Yes or no? Tell me yes or no. Right? Yes. For example, it is displaced slightly and it moves such that it is constrained. Now, if it is displaced slightly, let's displace it, right? Let's displace it. Okay. From here to here, let's displace it. Okay. Now, if you're displacing it, right? Tell me at this point, what will be the energy? Tell me at this point, what will be the energy? Everyone think about it. Total energy will be, which will be what? Kinetic energy plus potential energy. Now this is height. This height is h. This height is h, which is actually y. Okay. So I can say, okay, total energy is equal to kinetic energy, which is half mv square plus potential energy, which is mg h, and here h is y, is equal to constant, because we know that total energy is always constant. Yes or no? Tell me. Yes or no? Anyone have any issue in this? About it. Step by step. Clear? Now we know that total energy is constant. So find dE by dt. dE by dt. So what is dE by dt, everyone? It will be half m dv square by dt plus mg dy by dt is equal to 0 because E is a constant. Yes or no? Step by step. Everyone is getting till this step? Tell me. Everyone is getting till this step? Okay. Now, since v square is not a function of t, right? So I can use chain rule over here. I can write half m. Now dv square by dt can be written as dv square by dv into dv by dt. Yes or no? Using chain rule. Plus mg, and this is what? This is dy by dt, which is equal to what? Tell me. Dy by dt, which is equal, here y is equal to x square by 40 now. So it is by 40, I'll just take common, it will be dx square by dt. Agree? Tell me. Agree? Yes or no? Step by step. Write down. Everyone write it down. Step by step. Anyone have any doubt in this? Till this step? Anyone have any doubt? Till this step? Clear? Okay? Right? So I'll rub this step. Okay. I'll just rub this. Okay. So I can say, okay, I'm getting half m. Differentiation of v square is 2v into dy by dt is acceleration a. Now this v is actually in which direction? X-axis now. Yes or no? Right? Plus half mg by 40. mg by 40. Now dx square by dt is what? Dx square by dx into dx by dt. Same. Is equal to 0. So it will be what? MVA, 2 will get cancelled, plus mg by 40 into x square dx, 2x into dx by dt is v is equal to 0. Yes or no? So v will get cancelled. 20. So can I say, okay, ma is equal to minus mgx by 20? Yes or no? Or a is equal to minus gx by 20? Yes or no? Tell me everyone, yes or no? Right? So this is na. So can I say, okay, omega square is equal to g by 20? So this was your energy method. I hope all of you understood this. This is energy method, right? This is the energy method now. Okay. So this is the energy method to find time period. Okay. Clear everyone? Take your time. Try to understand this concept. Right? Let's see question number 10, everyone. Let's see question number 10. So the velocity time graph is given. The velocity time graph is given. Comment on the values of following. Position of the particle from its mean position. You just have to comment, right? Initial position, tell me where it is. To the left or to the right? Tell me. Suppose it is this point, right? 1, 2, 3, 4. I guess all of you can solve question number 10. It is just conceptual. Yes or no? Tell me yes or no. Right? If I'm saying this, if I'm saying that this is a pendulum, okay, this is a pendulum, right? So initially it is at this point. Initially it is at which point? This point, right? Yes or no? Initially it is at this point and it was going in this direction initially, right? Then it reaches maximum. Point 1 is again this point, but it is coming down. Point 1 is again this point coming down. Yes or no? Tell me. Think about it. Then point 2 is actually this point coming in this direction, means coming in positive this direction. Okay, so this is velocity, guys. Sorry, this I thought it is a displacement, but this is velocity. Okay, my bad. So for velocity, you can think about it, right? Velocity, you can think accordingly, right? If it is x by t, then this is the expression. I'll explain this first. Okay, then 3, again this point, it is going in this direction. 4th, this point. Okay, then again any point will be there. Okay, it will be in this direction. So this is for x. Now for velocity, we know that for velocity, okay, wrong then, OS, it will be wrong. Okay, now acceleration, I hope all of you can find. Yes or no, tell me. Direction motion, I told you, see, third one I told actually. Third one I told you, yes or no, direction motion. Agree everyone? Yes, clear? So this is just conceptual, okay? Now question number 10, question number 10. So displacement of an object is attached to a spring and executive SHM is given by this. Find the time at which maximum speed occurs first. Easy. Dx by dt is equal to 0. Right? Find t. Yes or no? Tell me yes or no. Tell me. Maximum minima, concept of maximum minima. Okay. 12th one we have solved, I guess. 12th one. What is the answer of 12th one? Look at the question number 12. So this is acceleration is f. Acceleration is given as f. Okay, acceleration f varies with time as this. Okay, the kinetic energy of the particle, the formula of kinetic energy is, tell me. So you have equation of x, no? You have equation of x. So you have find the equation of kinetic energy. Tell me. Easy? Guys, tell me easy. What would be the answer of this? Tell me, what would be the answer of this? Think about it. Yes, very good, Ria. Very good, Abhiram. Answer is D. See, at initial point, always think initial point, right? Acceleration is what? Tell me, acceleration is what? Maximum or minimum? Tell me, acceleration is maximum. Acceleration is max. And we know that acceleration is max at extreme positions. Yes or no? And at extreme positions, velocity is 0. So this, okay? Then too you can solve. Then too it will be like this only. Okay. Okay, everyone got it? So this is your in-class exercise. I hope all of you understood this. So this is the second problem, everyone. This is the second problem. A particle executing SHM has an amplitude of 6 centimeter. Its acceleration of distance at distance of 2 centimeter from a mean position is 8 centimeter per second square, right? The maximum speed of the particle is. Guys, these are formula putting getting problems that you guys wanted. Okay, me? Okay, Jasaran? Okay, Sri Sneha? Message the box, message the chat box. Okay. No issues, Ria. You can just see the screen and then mess in the chat box. Okay, right? So see, I hope all of you understood this problem. Okay, so if you see the problem, I can say that acceleration is equal to minus omega square x. But again, negative sign is just for direction. So I'll just take omega square x. So acceleration at distance 2 centimeter from mean position is 8. So x is given, a is given. You can find omega, yes or no? Tell me, yes or no? 8 is equal to omega square into 2. So omega is equal to 2. Clear? 2 radian per second. Yes. Okay. Now, maximum speed. We know that maximum speed is omega into a. V max, which is 4 into 6, which is 12. Easy? Got it? Formula putting getting? Next. This is basic conceptual problem. What's the phase difference between velocity and acceleration, right? That's it. That's all you have to say. Okay, Shriyari. Okay, Meet. Yes, so that question, very good. It is pi by 2. Very good, everyone. Right? Very good. Because one would be cos, the second one would be sine, right? So pi by 2. Next. Now this is a good problem. This is a good problem which consists of concept of maths, right? So I have to tell you this, but let's see how many of you can solve it. Okay, me. The answer is 0. Now, think about it. Think about it. Yes, Shriyari, correct. So when you talk about average of any function, okay, average of any function is given by, right? Suppose I'm having a function f of x, okay, f of x is a function. So the average of f of x is given by integration of f of x dx, right? Okay, or I'll just take t, right? F of t. So average f of t average value is given by integration of f of t dt divided by integration of dt from 0 to time period t, 0 to time period t. This is the basic function of average, right? Everyone remember this. It is used a lot in physics, okay, especially in class 12. Okay, right? Note it down, note it down. Now, tell me, what is the average? What is the formula for acceleration? It is A is equal to A naught, which is omega square x. Okay, sine omega t, yes or no? Tell me, yes or no? Tell me, yes or no? Yes. Now, what do you think? What is integration of sine omega t? What is integration of sine omega t? Cos omega t. Agree? And cos omega t from 0 to pi. Sorry, 0 to 2 pi. Time period, na? 0 to 2 pi. So, tell me, 1 minus 1 will become 0. Yes or no? Tell me, yes or no? Clear? Tell me, clear? Okay, everyone is clear in this? Right? Okay, very good. Next. So NEET students, remember that concept. Math students might already know, okay, but NEET students, you need to remember that concept. An object of mass m is suspended from a spring and it executes SHM with frequency n. If the mass is increased 4 times, the number of frequency will be. Think about it, easy. Formula putting getting, guys, formula putting getting. Okay, Meet. Okay, Shrihari. Okay, Jashan. Okay, Sneha. This is frequency, not angular frequency. The question asked is frequency, not angular frequency. Okay, you have solved this, right? Now, third concept test. We'll solve third concept test, everyone. Okay, let's try to solve this, everyone. Let's try to solve. Have you solved this? Yes or no? Tell me. Have we solved this concept test? Let me know. Guys, let me know. Have you solved this concept test? Yes? What is the answer? Tell me, what is the answer then? The answer is C. Yes. Okay. So this concept test, I guess we haven't solved this one, right? Try to solve this, everyone. Try to solve this. What's the answer of this concept test? Okay, Abhiram. Okay, Ria. Everyone think about it. Everyone think about it. Okay, many students are saying A and B. Okay, the answer is B. Okay, guys, the answer is B. Because obviously, when you talk about energy, right, think about it. Okay, mean position means potential energy is zero. The kinetic energy should be total energy. Yes or no? That's why the answer is B. Got it, everyone? Tell me, got it? Try to solve this. Next concept test. This is not based on compound pendulum. Obviously, I know that compound pendulum is not over, right? This is not based on compound pendulum. Tell me everyone, this will be the last question of today's class. We'll play the remaining Kahoot in next class after MT. What is the answer of this one? Tell me, what is the answer, guys? This is basic conceptual problem. Very basic conceptual problem. Okay, the guys, the answer is C. Okay, the answer is C, right? Think about it now. Think about it. Even if you change the orientation, X will change accordingly. Right? Yes or no? This is what we have studied. Yes or no? We have basically studied this in last class, that even if you make it vertical, horizontal, or any at any angle, the time period will not change. Yes or no? How many of you remember this? Yes or no? Okay, right? Okay, okay, everyone. That's it for today's class. I hope all of you understood the basics of 13.1. Okay, so I'll continue with 13.2 in next class, which is after your MT. Oh, that's what we said, nah, right? If it is inclined, the equilibrium position will change, right? Yes or no? Tell me, equilibrium position will only change, nah? Right? We have derived this also. Think about it. How does horizontal, right, inclined and vertical? Think about it, right? Okay. So next class, I'll complete your compound pendulum, angular oscillations, right? And damping. These three topics are remaining. So we'll be completing all those three topics. Okay. In next class on Monday. Okay, everyone. Right? Prepare well for your MT.